Hi all, welcome back to my lecture series. This is Muthuminal R, Assistant Professor from the Department of Agricultural Engineering at SNS College of Technology. Today we'll see the topic on water resources inventory and water quality assessment that comes under the unit application of RS and GIS under the subject Geographical Information System for the students of third year fifth semester. So before going into the session, let us have a small recap what we have seen at the previous lecture series. We have seen what are the data products and how these data could be used under spatial analysis, what is crop acreage estimation, and how we can use GIS techniques in understanding crop condition, and also how we can map the soil erosion. So today we'll see what is water resources inventory, water quality assessment, water management, water resources and quality challenges. Now let us understand what is water resources inventory. As we all do know that GIS and RS are essential tools used to understand, access and manage the water management, that is with the help of soil erosion mapping. The methodology for mapping these kinds of vital inputs will provide us water quality modeling, particularly in identifying sediment source areas and also understanding surface runoff potential within a watershed. So what we have to do here in the sense, we have to use a systematic process of identifying, quantifying and evaluating water sources, their spatial extent, temporal dependability and quality characteristics to ensure sustainable utilization for human and environmental needs as defined by the WMO. Here, initially what we have to do for identifying the water resources inventory are, we have to assess the runoff and determine the vulnerable areas. For the purpose of assessing the runoff, initially we have to use the potential of mapping the soil erosion and prevent them from causing environmental deterioration that are associated with the misuse of lands. By using GIS to integrate and analyze the data, experts can determine where the surface runoff is and likely to occur, which directly impacts water movement and quality. The first which we have to take into consideration is data integration, that is erosion that studies the require integrating multiple layers of spatial data. The second one that we have to consider is surface runoff potential, where GIS associates surface runoff potential as an attribute with each land cover type. Next, what we have to consider is locating high risk areas. So the high risk areas are usually developed into a soil loss equation, that is universal soil loss equation and revised universal soil loss equation, in order to indicate the high soil erosion potential, that is high erosion risk. Then watershed analysis, which helps us to assess the erosion potential, often done throughout an entire watershed, which is the fundamental spatial unit for water resources inventory and management. So the next condition which we have to take into consideration to avoid those problems are monitoring physical indicators of runoff. As we all do know that remote sensing provides capabilities for continuous monitoring of landscape changes that impact water quality, such as the formation of erosional features. So in order to do so, a significant physical indicator of erosion visible through imagery is the formation of erosion gullies. So these gullies are small drainage features 1 meter wide and 100 meters long that results when rainfall runoff of unconsolidated material that cannot be adequately percolate into the ground. So this is how the gully plays a major role here. So what we have to do here in the sense, in order to avoid these kinds of problems, we can provide a gully indicator. The gullies in sand and gravel exhibit short V-shaped cross-section, and also the gullies in silt soil show U-shaped cross-section. Gullies in silt, clay and clayey soils tend to be long with gently rounded cross sections. So if we identify the physical characteristics of the gully, obviously we can avoid the problems or the changes in the landscape. So by mapping these erosion prone areas and monitoring the formation of gullies, water managers can prioritize intervention upstream to reduce sediment load and nutrient transport, which are critical components. So this is how the main critical components like water quality assessment, vulnerability landscapes, erosion rates and erosion prone areas could be redefined. So these are some things which we have to take into consideration. The next one is mapping inventory. So obviously, as I have said you, the mapping inventory could be done by considering the water inventory components like surface water, groundwater, rainwater harvesting and water infrastructure. So initially what we are going to do here in the sense, we have to collect the data by integrating the remote sensing field surveys and historical records. Then we have to analyze them under spatial analysis where the delineate water bodies could be analyzed, and we have to integrate the layers by combining the topography and the climatic factors and land use data. Then obviously we'll come with an inventory output that will help us to generate comprehensive water resources atlas. So today we have seen about GIS and RS for water resource management. We have seen what is the fundamental application, how we can assess the runoff, and monitoring the physical indicators and water management outcomes. So this is the main thing that we have seen today. So let us go to an activity. For today's question, in geographical information system, what fundamental concept defines the spatial relationships between features such as adjacency, connectivity, independent of their coordinates? The options are georeferencing, map projection, topology, and rasterization. So our answer is going to be map projection. And okay, so here is the references which we have followed up for today's session. If you guys have any kind of doubt or anything, you guys can ping me anytime. See you at the next class. Thank you.